Hello. Today we're going to talk about 6.7, inverse relations and functions. All right, so first you need to know what a relation is. It's just a set of ordered pairs. Any ordered pairs, doesn't really matter. No, not really. It doesn't matter, okay? It's just a set of coordinates, okay? A function is a certain type of relation with all different domain values. So think of it as like a square and a rectangle. A square is a more specific type of rectangle, right? Oh, that is a terrible rectangle. Okay? A function is a more specific type of relation. All right? The inverse relation is when you switch x and y. Okay? If a relation and its inverse are both functions, then they're called inverse functions. If they're not both functions, then you can't call them that. Okay? An inverse is not always going to be a function. So, let's talk about what an inverse is, how to find it. Okay? So you're given this function. You know it's a function because it says f of x. All right? Now, f of x is kind of like a fancy way of saying y. So y equals 3x plus 2. Well, the definition of an inverse is to switch the x and y around. So y is now x, and x is now y. Nothing else changes. Everything else stays exactly put. Only the variable changes. So now we get y by itself. So we move that 2 over. Then we get rid of the 3. So we divide. Now, to note, for notation, so we label this as an inverse function, we need the f of x because that's a function, but then we put a little -1. It looks like an exponent. It's not. It's just notation. All right? So this is the inverse function of f is equal to x minus 2 over 3. Okay? All right, so let's find some more. So why don't you practice this? Pause it, give it a whirl. All right, number 4. Write it as a regular function or equation. Switch your variables. Move things around. So your inverse function is x minus 8 over 2. Now, for number 5, this is the one I usually get kids on. Okay, well, anybody on. So we get y equals x squared minus 1. Flip things around. One thing, notice the exponent didn't move. Everything stayed still but the variables. We get the 1 over. Now, the opposite of squaring, this was last section, the opposite of squaring is the square root. But hold up, all right, red flag here, we added the square root. All right, so when we add the square root, we need to add plus or minus. Okay? So the final inverse function is plus or minus the square root of x plus 1. All right, so now we found the inverse functions. Let's find whether or not the inverse is a function. Okay, the inverse of a function, okay, means the domain can't repeat. So what it means is one x value for one x value has only one y value. That's the key for knowing if its inverse is a function or not. So if we were to plug in a number here, doesn't matter what it is, if I plugged in 0, I would get -4. So there's no possible way that I can get two different y values. So the inverse is a function. Think about this. This is also x over 2 minus 8 over 2, which is 1/2 x minus 4, which is mx plus b, which is a line, which is a function, right? If you graph any line, as long as it's not a vertical line, that's a function. Okay, so this is actually a line because it's in slope-intercept form when I convert it. Now, let's see. Now we look at this one. Well, if I plug in a value, so when x equals 0, we get plus or minus the square root of 0 plus 1. Plus or minus the square root of 1, plus or minus 1, I get 1 and -1. I don't like that. That makes me very sad. Okay, so the inverse is not a function. Okay, that's how we can tell that plus or minus tells me that there's not, there's going to be two values for y, and I can't have that. All right, so for the last two that we're going to try together. Well, first you can try them on your own. Feel free. Now, here's how I would do it. You get y equals 3 minus 7x. Switch them around. X equals 3 minus 7y. Move the 3. Divide by -7. There's our inverse function. Now you can write it like that, or if you want to write it as like actually dividing each part by -7, that would be -1/7 x plus 3 over 7. So notice that is a line. Okay, so it's nice to notice that. Okay, for our domain, the domain of our original function, that's a line, so the domain is just all reals. And notice that our inverse is also a line, so the domain is all reals. Okay, if you were to graph that, it would, well, these have negative slopes, so it looks something like this. So x can be anything, and x never repeats. Now, for number 9, we have y equals 3x squared. So we get x equals 3y squared. Divide by 3. Ooh, that is a rough looking 3. There we go. The opposite of squaring is square rooting, but when we do that, we have to put plus or minus. So that's our inverse function, but we need to rationalize that. So think about that. That's the square root of x over the square root of 3. Multiply by the square root of 3. You get the square root of 3x over the square root of, over 3, or the square root of 9. All right, so make sure you rationalize. Okay, so we get plus or minus the square root of 3x over 3. All right, so now determine if it's first find the domain, and then we'll do the inverse. So this is the domain, is in blue. So the domain of the original one, hopefully you realize that when you see it's x squared, that's a parabola, which means it looks like this, or this, all right, when it's x squared. So we know that that domain is all reals. All right, now for this one, notice we have the plus or minus. Okay, that's when our y's start to repeat. Okay, so, I'm sorry, I'm answering the other one. Let's just focus on the domain. Well, here we just focus on, hey, there's a square root. There is a fraction, but there's no variable underneath there. So saying 3 doesn't equal 0 doesn't do anything, okay? That's useless. Okay, but we can do 3x, what's underneath the radical, has to be greater than or equal to 0. So x has to be greater than or equal to 0. So the domain here is, oh, what am I doing? Interval. All right, we're going from 0 to infinity. Now, to determine if it's a inverse, well, lines, oh, wait, no, hold on, what am I thinking? I'm trying to determine if it's a function or not. Determine just the domain. That's all we were doing here. Okay. If we wanted to determine if it was a function or not, okay, this is a function because it's a line. This is a function, it's a line. A parabola is a function. And then this one, since there's plus or minus, it's not a function. All right, because those y's repeat, and we can't have that. All right, if you have any questions, come see me in class.